A new space mission for potentially habitable planets around Earth's star system is underway. An international collaboration of scientists in Australia and the US will search in the Alpha Centauri star system for Earth-like planets that could sustain life. Alpha Centauri, Earth's closest neighboring star system, consists of two Sun-like stars, known as Alpha Centauri A and B, and a more distant red dwarf star, the famous Proxima Centauri. The TOLIMAN mission, named after the ancient Arabic-derived name for the star system, will search for potential planets orbiting Alpha Centauri A and B. The TOLIMAN telescope, which is under construction, is set to be launched into low Earth orbit in 2023. It seeks to discover new planets in the Goldilocks orbit, at the right distance, so the planet is neither too hot nor too cold to sustain life and where liquid water could be present at the surface of the planet. The signals planets give off are very subtle and very faint compared to the signals from stars, which makes hunting for planets like solving a mystery. Despite the seemingly frequent discovery of exoplanets, planets outside our solar system, around our very nearest sun-like stars, we don't have any idea whether there could be any Earth-like planets. The TOLIMAN mission will try to uncover planets by studying whether the stars Alpha Centauri A and B wobble from side to side due to the presence of unseen planets tugging on them gravitationally. But what kind of knowledge exactly will this mission bring to us on Earth? First of all, TOLIMAN is an innovative low-cost mission that will be the first capable of revealing potentially habitable planets around a handful of the nearest solar-type stars to the Sun. Rocky planets in habitable orbits among our immediate stellar neighbors will change our understanding of the universe, not only from a physical perspective, but also in philosophical and ethical ones. If everything goes well, TOLIMAN will enable detailed characterization of atmospheres and surfaces and prospecting for potential biosignatures. What are they for? Well, if you think about it, science is made of small pieces that, together, form the big puzzle of the universe. On long timescales, TOLIMAN's data may furnish targets for futuristic robotic probes. These data will reveal the presence, orbit, and mass of all orbiting exoplanets. The primary target for this mission will be the detailed studying of Alpha Centauri A and B, and the objects down to 1 Earth mass will be accessible. But how will the TOLIMAN mission gain this data? It will use the astronometry method. Astronometry is basically the only technology capable of detecting all Earth mass planets in the habitable zone of very nearby sun-like stars such as Alpha Centauri. Do you know how many planets we're discovering per day? The rate is something like 1 new exoplanet per day. And yet, if we wish to know whether any particular stars hosts a rocky planet in the habitable zone, we have a tiny and remote chance of being able to find out. Most of these detections were just guided by luck. Missions like Kepler gave us information on the statistical incidence of the planets in various stellar environments. But we still don't know if the nearest of the sun-like stars such as Alpha Centauri, Tau Ceti, and Epsilon Eridani actually host a potentially habitable rocky world. Even worse, with present technologies, we have no way of finding out. That's the reason why we need new improved instruments to do the job. And TOLIMAN is exactly what we need. TOLIMAN will be actually a quite modest astronomic space telescope designed to discover and perform dynamical characterization of rocky planets. It is not so big, having a 30-centimeter diameter, and it will be of course a space telescope, meaning that we'll need to launch it first. The mission will yield immediate constraints on the orbit and mass of any detected planets from the habitable zone out to the dynamical stability limit imposed by the binary. If such a planet is found in the nearest solar-type solar system, it will be a game-changing discovery that will trigger intensive characterization efforts. TOLIMAN will also observe a handful of A, a handful of F, G, K spectrum stellar targets within the immediate solar neighborhood, variously probing down to Earth or super-Earth mass. At the center of the TOLIMAN mission, there's a new type of telescope which makes use of diffraction lens. This mirror diffuses the starlight captured by nearby stars in a complex floral pattern, which, paradoxically, makes it easier to detect the perturbations of stellar movements, signs of the presence of planets in orbit. But what makes TOLIMAN such a special instrument? Its empowered optical architecture. It promises to deliver the required micro-arc-second astronomic precision. When trying to reference stellar positions at micro-arc-second scales, a lot of imperfections and mechanical drifts, even the smallest defects, can create instabilities that can be orders of magnitude larger than the true signal since it is very low. Rather than trying to directly contain all these errors, the diffractive pupil approach sidesteps them by creating new astronomic ruler to register the star's position, one formed from the starlight itself. The diffraction pattern from the pupil broadcasts a reference grid onto the detector plane against which stellar locations are registered. The genius of this approach is that the diffractive grid of starlight suffers identical distortions and aberrations to the signal being measured. Drifts into the optical system, therefore, causes identical displacements of both the object and the ruler used to measure it. And so the data are immune to a large class of errors that beset other precision astronomic experiments. Hopefully, TOLIMAN will become an inspiring mission for future generations of astronomers and scientists all over the world. Who knows? Maybe, in the next years, we will rewatch this video together with our new friends, the inhabitants of the Alpha Centauri triple star system. Or, it could be that our sons and daughters will still be working on this mission because science takes time and effort. That's it for this video. Let us know what your thoughts are about this mission, and we'll definitely see you in the next video as we dive into another discovery in space.